Good evening, hackers. What's going on? Taggart here for another stream. We're going to be doing some Linux challenges tonight um, at overthewire.org. And we've done a little bit of this before. I love this. I love this site. It's so old school. So we're going to be doing Bandit, and we've done quite a few of these already. Um, but we're starting at where we last left off was level 24 to level 25, and the basic idea with these is you go through and you complete the challenge, you get the password to log on as the next user via SSH. And level 24 to level 25, I've actually completed it, but I want to just show it to you because it's crazy. At least the way that I did it was crazy. So a daemon is listening on port 30,002, and we'll give you the password for Bandit 25 if given the password for Bandit 24 and a secret numeric 4-digit pin code. There's no way to retrieve the pin code except by going through all of the 10,000 combinations called brute forcing. So it wants you to do a brute force, and the Bandit machines are slow. So I was trying to figure out a way, like, okay, I know that I'm going to be kind of at the mercy of the response speed, but could I at least, improve the compute speed so that the only bottleneck really is the back and forth of the TCP, which is even over the loopback interface, so there's no like network lag to worry about. So I wrote the brute forcer in Rust, so that might be kind of cool to see. Here's what the brute forcer looks like. We're using a lot of the standard net stuff. Let me get some tunes going as well, just so we have some backing. I'm thinking a little jazz tonight. We'll see how this goes. All right. Those levels seem to be pretty good. All right, so what are we looking at here? We use the standard network libraries from Rust, shutdown to close the connection, and TCP stream to handle the connection. And what we are building here is a struct called a buff TCP stream, and basically, because we need to keep track of what's going in and out, it's not just unidirectional, right? We have to build in this buffer reader and buffer writer. And you can see that we're actually getting buffer reader, buffer writer from the standard IO library. So essentially we're wrapping those buffered reader and writer structs inside of, or we're wrapping TCP streams rather inside of those buffered readers and writers. And that allows us to kind of write to and from the buffer, or write to the buffer going out and read from the buffer coming in with a little bit more ease than we otherwise would. This is actually the password for 24, level 24, and I just kind of hard coded that in here with a space because the idea is you're going to send the daemon that's listening on port 30,002. You're going to send that the level 24 password and then the 4-digit passcode separated by a space. So we're just putting the space in there so we don't need to worry about it later. And we're starting it off with just creating the format string that way. Now, obviously we're going to be doing digits 0 through 9,999, right? Or integers 0 through 9,999. But, if we just do the integers, that won't have the zeros prepended, right? Until we get to that place value. So to do that, I'm creating this pad length here, which is basically saying, okay, if it's a 2-digit integer, right, like 20, then my padding is 2. That's how many zeros I need to put in front of it. So I create a new string for the code, and I push the password onto it, and then I push as many zeros as the pad length is, and then a new line, because the new line is what the TCP listener is going to be waiting for to trigger the response. Here, this is a cool thing I love in Rust, right? We can have tests in line. So I just wrote a little quick test for my own sanity to see, does the secret code generate correctly? And this does pass. I'll run it. Let me run it over in this window. And let me bring this down so that it doesn't go below my head. Thank you, T-Mux. And we'll go to Bandit 25. And yeah, so we do cargo test, right? It'll compile, and then it'll run any tests that are labeled with the test decorator here. And you can see here it runs one test code generates correctly, and it says okay. So real handy to just have those tests in there. I could have been more explicit with some of my tests, but that's what I had going on. And then this is where we actually do the work. This is the brute forcing right here, where we, this is our kind of top level, and we connect to localhost 30,002. Basically what I did was I compiled this thing, and then I uploaded it to the Bandit server and ran it from there, because I built it to the same target operating system and architecture. So we create that buff TCP stream, and then we create a text buffer. We read the line from the text buffer into, we read from the buff stream into our text buffer, and then we print it out just so we can see it. Consuming is important, right? Because we need to clear what's in the buffer before more stuff can come into it. And then we clear the buffer, or we clear the string, right, where the text buffer lives, and then we generate a new code. We write the thing to our outgoing buffer. Flush sends it off, and then we get the response back with a read line. We consume that out of the read buffer, and we keep going until we find the so the test string here is the string wrong. Every time that we get it wrong, it says wrong. So I'm just checking on every loop to say if it contains wrong, then we're going to keep going. Otherwise, we print success and whatever the secret code was and break. So anyway, this worked. It took some time, but it worked, and it was cool to do this in Rust. And the result was... this password right here. I hope. Oh no! Uh-oh. Looks like I didn't save it. Well, glad I explained all that, because it looks like I'm going to have to run it anyway. Unless I saved it in both places, which is... that's the new password. It's possible. Oops. Let's see how that goes. Let me SSH into Bandit 25. Well, let me try to SSH into Bandit 25 with that password and see if it works. If it doesn't work, because yeah, I'm not confident because I've got it's the same as the password in the source code. Yeah, that's not gonna work. Okay, well. All right, well, here I am in Bandit 24. So I guess let's run this brute forcer that I've been talking about. I have it built already, so if I go to Target, not the department store, and cd build. Oh, I didn't compile it for release. Oh, I should do that because it'll be a lot faster. So cargo build, yeah, release. There it is. Okay. So there's the Bandit 25 executable. We're going to SCP that thing. Yeah, literally exactly like this. Oh, looks like I lost my music. Let's see if I can get it back. Sometimes Twitch soundtrack dies on me. There we go. Okay. Password. Okay, so it's uploading. And oh. Well, can I just run? So it's there, but it's blind? Yeah. So there it goes. It's gonna take a while. So unfortunately, we're gonna have to do some other stuff while that is while that's running. Well, that's okay. We can get up to some other nonsense. What if we did some Python while we're waiting? Little we can go back to exorcism. We can do some Code Wars. While we're waiting for this thing to brute force. Let's do some more exorcism. That was fun. Getting all my stuff back up. So, exorcism window. Don't remember why we had so many of these open. Okay. And I don't remember which language we were, or what challenge we were on currently. So let's see. Oh, we were doing Matrix. What? Eh. Oh, wait. Yeah, we did do this one because it was like... Yeah. Because we got it the one time, but then we wanted to make it more computationally efficient. Yep. Okay. So, let's try it. Let's start a new challenge here. Let's do... REST API hard. That's interesting. Wow. They're not kidding. I mean, that's a real project. RNA transcription. This is a fun one. Oh, no, not Bob. I hate Bob. All right. RNA transcription. Real simple. Given a DNA strand, return its RNA complement per RNA transcription. The 4 nucleotides found in DNA are adenine, cytosine, guanine, and thymine. The 4 nucleotides found in RNA are adenine, cytosine, guanine, and uracil. I remember this from AP Bio a million years ago. Yeah, the T and U swap. And they have complements, right? So guanine binds to cytosine, cytosine binds to guanine, thymine binds to adenine, but adenine in RNA, instead of binding to thymine, binds to uracil. So it's basically going to give us a DNA strand, and then we have to produce the RNA transcription. Okay? Nice and simple. So let's get that going. Okay. Okay, I think I'm over this jazz. We'll go to the lo-fi. All right, let's get our stuff open. Nope. So it's always nice to read the tests first. I think I made that same spoonerism last time. So we're just going to translate C to G, G to C, T, A, A to U, and then it gives us an actual strand. Now, there are a lot of really fun ways to solve this. So I think we're gonna toy with this one a little bit. Okay, so the first one is straight up iterative, right? Like, this is as bare bones as we could possibly write it. Let me just check on our brute forcer. Still going. Although it's making good progress. Okay. So let's see. Right. Call it N for nucleotide in DNA strand. And then this is, like, again, as bare bones as we could possibly do it. Oh, we need to have a starter string, right? Say RNA equals empty string. If N equals A, RNA plus equals, what is it? DNA A becomes RNA uracil. So A to U. LFN equals T. That becomes adenine. Now, in our tests, they're not throwing any curveballs at us, right? They're not sending us like a cue or something. But we should probably program for it. So we'll say LFN equals C RNA plus equals G, and then we'll just say else, continue. So we won't do anything if there's no sensible character. And then return RNA. Okay? Straight up iteration, right? No frills whatsoever. And this should run. And yeah, it passes, no problem. But this isn't the only way we could do this. This problem lends itself pretty well to a recursive solution. So let me comment out this version of 2RNA, and let's make a new one. Okay, so in this version, we're going to go recursive. And recursion, let me just check on the brute forcer. See how we're doing? All right, about 25%. We don't know how long we need to go. I feel like the number was somewhere in the 3s, but I don't remember. So, okay, so 2RNA recursive. The idea with a recursive algorithm is that the same function is called again and again and again until you reach what's called a base case. And that base case will return a single value one way or another. Palindromes are really good examples of this. So for example, if we were to write, if we had a palindrome, right, where it was like race car, right, which is a palindrome. If we wanted to write a function that tested whether something was a palindrome or not, we could do something like, okay, if the length of the base case, what's the simplest palindrome? That's the base case. The base case of a palindrome is a single character. A single character is always a palindrome, right? Because it's the same forwards and backwards. So if the length of the string is 1, it always returns true, right? Always. If the length is 2, you do have to check to see if the thing reversed, like if they're swapped, right? But if it's longer than 2, you can do this kind of cool thing, right? Where you can say, okay, rather than check all at once whether each position is symmetrical, I can say, okay, does the beginning match the end? Yeah? Cool. I'm going to take those off. I don't care about those anymore. And I'm going to send the smaller piece of the string back around into the same function. Then I'm going to check again for the beginning and the end. That's all I have to do. And if they don't match, fine. Then we return false. But if they do match, then I do again. I take those edges off and I return the smaller version of it. So we're going to kind of do, with 2RNA, we can do the same thing. So 2RNA, what's the base case, right? It's the single base pairs, right? The single nucleotides, right? But if it's longer than that, we're going to return the translation plus the recursive call to 2RNA. So here's what this looks like. And in actuality, I'm going to write a helper function here. In which we basically do what we're doing up here, except with some modifications, but you'll see how that goes. And I'm just doing a little bit of Vim magic here to get my commenting out. Now, instead of RNA plus equals, I'm going to say return. This is the hard one to do. Forget it. I'll just do this manually. It's not too tricky. Now, if I wanted to make this even more efficient, rather than doing all these returns, in fact, this is actually what I want to do. Instead of a helper function. Just kidding. I'm not going to do it this way. I'm going to do it this way. I'm going to say, we're going to store it in dictionary. So rather than doing, we're going to take advantage of compute storage space rather than compute. Right? So adenine becomes uracil. Thymine becomes adenine. Now, with transcription written that way, in this handy dictionary, I can say, let's do the base case. So, if len DNA is equal to 1, we're going to return transcription DNA. So we're looking up the transcription table here, and then we're using the DNA's key, DNA nucleotide here, which we know from this conditional is just length of 1, and we're returning whatever that string is. Now, this isn't finished, but because of the way the tests are written, this will actually pass all but, well, 2 of our tests. We'll actually put this in a try catch. Try accept. Return an empty string. And that actually should pass all but 1 test. Okay, all but 2 tests. Oh, right, of course. I actually never got here. Because that was a different base case. Okay, so now I'm only failing the longer string. How's Was our brute forcer? Oh, I think our brute forcer finished. It did. Although, this is 2588. I forgot to... freaking write the password in my code. Okay, let's not forget to do that this time. And we'll go back to Bandit in a second. But we gotta finish this Python now that we've started it. Okay, so to finish the recursive version of this, we've got two base cases, right? A length of 0, a length of 1. Now, let's say if it was anything else. And in fact, we'll make this an elif, right? And then we'll do one final else. With this, what we're going to do, so cool, we're going to return transcription of DNA of the first index, right? So we're going to transcribe the first character, right? Then we are going to concatenate it with to RNA. So we're going to call the function from within the function. And what are we going to send to it? We're going to send it the DNA strand with the first character chopped off. So that would be DNA starting at index 1. That's how we'd slice that out. And actually, I'm going to throw a print statement in here to print DNA, just so we can actually see it work. That didn't run it. Well, that's fine. We can load it up and run it. Import from RNA transcription import. So let's try to RNA AATCGGT. Right? See that? So it's taking each successive, right? It's taking the first character off each time, right? And it's translating each one. Now, you might be thinking, wait, why don't I see the result until the very end? Right? Because what's happening is, in the case of a longer string, right, anything longer than 1, it just returns. And so what's happening is I'm trying to do a concatenation, but then every time I go to add something, it's getting caught with this function call. So it's going down several layers into the function call until we hit that base case of 0 or 1, right? In this case, 1. And then we get the final transcription. Once this returns, it all kind of comes back out. Anyway, recursive solution to this. That's the one that I like, so that's the one that I'm going to submit. Okay. All right, back to the Bandit. Now, we can exit out of there, and we have the correct Bandit 25 password this time. And so we're gonna SSH into Bandit 25 with that correct password. So let's see what the description for level 25 is here. Logging into Bandit 26 from Bandit 25 should be fairly easy. The shell for user Bandit 26 is not bin bash, but something else. Find out what it is, how it works, and how to break out of it. Interesting. Can I read this? Interestingly, yes, I can. Okay. Well, let's just save that. Using my trusty Tmux here. And I'll fire this off. And I'm going to chmod it to 0600 bandit 26 dot key. Okay. But now there was that hint about the shell being different. So let's see if we can cat Etsy password and grep for bandit 26 to see what the shell is. User bin show text. Interesting. I don't know what show text is. Stat of... Okay, so we don't really know what... It's ASCII text. It's a POSIX shell. So, oh, I can read it. Oh, okay, cute. So, show text is just, it's bin sh, and exporting term equals Linux, okay, and then more equals text.txt, and then exit 0. I don't suppose I can write to this thing, can I? No. No, can't do it. Well, let's try it. So I'm gonna keep my current SSH session open, but I'm gonna open another one with Bandit 26 and the I of Bandit 26.key and see what happens. More text.txt. Let's see what that is. I know there's a trick to this. I always forget how it works. I think it's like a trick about how SSH works. Okay, it's gonna be something like this. So can I send commands? Let's try that. Nope. I can't read that either. That's unfortunate. Oh wait, dash TV. For pseudo-terminal allocation verbose mode. Okay. Oh. So let's actually try sending the command q. Oh. Does more have, a shell breakout? Yes, it does. Okay. That's how we're gonna do that. Okay, so we're gonna send bandit.key. Damn it.
Hey man, ain't no way I'm gonna be up and have my nigga out here looking broke. I don't understand these niggas. Oh, wait.
I first tried it because other kids were trying it. When I feel real bad about something, it was a way of getting to feel better. It seemed everyone I knew was taking something.
Oh. What's this dash T? No, that's just... It's cute. Okay. Problem here is that it's not, it's not a restricted shell the way we usually think about a restricted shell, right? Because it's not a restricted shell like it's a shell. the problem is that it's just this more file. And then exiting 0. I don't think I need the verbose. Yeah. Well, I can see if I'm getting actual execution, even if I can't see it. Let's try to set up a netcat listener. And see if I can get it to trigger a netcat here. Nope. I don't know. I wonder if there's something else we can do with the man page. Or, yeah, with more through the man page. All right, maybe if we start, because we didn't enter shell, but if I just hold down the V key. Okay, well that didn't work. Let's get rid of the TV and just... Dang it. Okay. Total stab in the dark. But what if... I'm totally in the wrong window. So more is about screen printing, right? So what if we... prevented all of it from printing out at once. Son of a gun. Okay, I didn't get Bash going, but can I get the editor going? Yes, I can. Now from here, can I get a shell going? No. Can I? Problem is my shell is wrong. Right? I can't run a shell command if my shell is whatever. Well, we can get the password anyway, right? Because it's in Etsy Bandit Pass. Yeah. Okay. It's actually, sorry. Right. So that's Bandit 26. Oh, we're in Vim. So can we do something like... There we go. Cool trick. Okay. Now, here's this bandit27.do. a command as another user. Okay, well now we're gonna edit Etsy Bandit pass Bandit 27. All right. Oops. Okay. All right. So now we're on 27 to 28. Cool. Okay, this is just a get thing. We can do a get thing. Sorry, I keep going to the wrong window. Okay, if it's just a get thing, we can do that. Git clone. Oh. Except it's not localhost, right? It's I gotta SSH first into it. Let's see that now. Okay, and then we're gonna run git clone here. Temp repo already exists and it's not an empty directory. What? Let's call it repo 27. That seems unlikely. Okay. So someone already did this. But okay. I'll take it. Very funny. They gotta clean up this server. There's a Git repository. Same deal. Let's see if there's a temp repo 28. Oh Why is this happening? Okay. This is the fastest I've moved through these levels since, like, the beginning. Probably not supposed to be doing it this way, but... incredible. What? What's in the code folder? There is at least code. Gift to ASCII. Is this, like, the end of it? Okay, hang on a second. Okay, finally, something important to do with repo 30. Let's do git log. Initial commit of readme.md. That's it? Just one branch? Aha ha ha ha. No, because that's just the remotes. I mean, I don't think this will matter, but we'll head over to the remote branch just to see. Nah. Is it actually an empty file? Yes. And that's the only commit, huh? Unless... No. Hmm. Hmm. There's no way that the commit is somehow the password. Is it? No. Okay. Gets not nothing in the stash. What can we do with Git? I just forget how Git tag helps. Okay. Git show. There we go. Git show. Tag secret. Or git show secret, maybe? Hello. Okay, let's try that. There we go. All right, so we're on 31. To 32. Incredibly, there's a repo 31. There's key.text. May I come in? What's in readme? File name, key.text. Content, may I come in? Branch master. This time your task is to push a file to the remote repository. Oh, that's it? Weird. It looks like I got the password, but it doesn't seem like the push validated. But maybe that's by design so that it doesn't ever validate for anybody. Yeah. Okay. Okay, welcome to the uppercase shell. Oh, it uppercases everything. I see. Cute. Hmm. Hmm. I don't know. But I think that's good enough for one night. So, we'll be back on Saturday, friends, and we will be doing some more defensive stuff. Saturdays are for blue team, and I think what we're gonna do is add another stream day. I haven't figured out what day I want to do it yet, but since Saturdays I want dedicated to blue team defensive training, but I still like doing the red team stuff. I think we're gonna find another day to do that, potentially Mondays. So stay tuned for that, but until then, happy hacking, everybody. I'm out of here for now, but I'll see you around on Saturdays.